All right. Hello again, everyone. Now that our juries are here, we are going to start our presentations. As I mentioned before, the team design category will do their presentations in the main room. Now, I have created two breakout rooms. We are going to ask all the case study competitors to join the case study room. After you join the case study room, our friends will guide you and tell you when you are going to make your presentations. Then you will go to the case study presentations room. All right, is there a problem in the breakout rooms, or did you understand clearly?
I can see the breakout rooms.
Let me check that again. All right. So can you see the case study presentations breakout room?
No.
All right, the Zoom makes me wait for 40 seconds to open another breakout room. I shared in the Discord the presentation orders with you so that you will know when are you going to do your presentations. As we mentioned before, you will have 10 minutes for doing your presentations, and the question and answer part. Our friends will take the time and warn you when the time comes. So yes, now I can open another room. So now can you see the case study room?
I don't see the breakout room button. Maybe you can send me here as the host.
Okay then. So can I ask a co-host to send the case study presenters to the case study room? Maybe Yaren or Hazal. Can you do that?
Can you tell that to me again?
We are going to send the. Wait, now I think. Now can you check again?
Yes, okay, now I see it.
All right, thank you. So, all right, without wasting any more time, we are going to start with the team design presentations here. First team was Team Maya, as you know, but unfortunately, they wanted to resign from the competition because they said they couldn't complete and they didn't want to go out to the jury. Because of that, the first team is, it's a hard one to pronounce it, Kinder. The team leader is Uğur Yolaç. Are you here?
Yes, we are here, Hocam.
All right. I'm making you co-host so that we can share your screen. And you will have 7 minutes and then 3 minutes followed by questions from the jury.
I'm making me host. Can you make Akın Süre host, please?
All right then. Akıncan Süre.
Can you please make me host?
All right. Now you can share your screen and start the presentation.
Okay. Let me for a second.
By the way, I tell you when to start, as I will start a timer and follow it. And if you exceed 7 minutes, I'll just have to stop you.
Okay. Let me finish my screen. Okay. Let me 1 more second.
No problem.
Okay.
Why don't I have the video? Niye göstermiyor?
Can you see my screen now?
Yes, we can see your
Yes.
screen.
Okay. Or if you wish, you can start.
Okay, thank you. Can you hear me well?
Yes.
Hello, ladies and gentlemen. My name is Uğur Yolaç. I'm studying mechanical engineering at METÜ. I'm a fourth year student. Today we'll present our project to you. Here's our outline. We'll first begin with introduction part, then we'll define the problem we have. Then we'll continue with the solution and design specifications. And finally, we'll explain analysis and instrumentation part in detail. And our team's name is Nachkriegskinder. It means post-war children in German. Sorry for inconvenience about pronunciation. And we are 4 students in mechanical engineering department at METÜ. To be able to, here are the skills that are necessary to be able to finish this project. Teamwork, design, and time management that we think we mastered so far. And now my friend Akın will continue with problem definition.
Hello everyone. Hello everyone. This is Akın Cansure, also a mechanical engineering student in METÜ, a fourth year student. In this design project, we have to design an environmentally friendly caravan in order to satisfy the conditions that researchers need, that where they can easily survive and make their researches and both daily and monthly routines. And also, this caravan should communicate with the research center in order to give the required information there. Let me skip the other page. Now my friend Enes is continuing with the solution part of the presentation.
Yes, I'm Enes. This is our interior design. And you can see there are 4 beds actually. You see 2 beds and there are 2 on top of each other. So there are 4 beds. And there is a bedroom and a toilet on the back of the car. You see kitchen counter, a table for experimental setup, and a very large storage area. And at the there is driver cabin. And now in the next slide, we will see the design in the side view. Now it's a bit complicated. It looks a bit complicated, but the beds are on top of each other, as you can see on the left side. The shower and toilet is there. The top of the driver's cabinet is also storage, and there's a large storage on top of the caravan, and there's an experiment table in the middle, as you can see. Now Akın will continue. Akın, open your...
Okay, I unmuted myself. In this part of the project, we designed a rail system, as it mentioned in the problem definition part. The rail system is just on the roof of the truck, and it's able to open and close by hydraulics. In this part, you see our 3D model of the truck. The dimensions are just same as the mentioned dimensions in the problem definition. You just see the three-dimensional views of that truck. Also in this part, you can see the base of the car and the tires of it. The tires are able to move in any direction, and they are capable of adapting themselves into the environmental conditions. Also in this part, you may see the sun parts to develop an energy, free energy from the earth. As you can see, we have in total 6 solar panels to have solar energy in it. And in this part, we have 2 beds. There is a mechanism that is capable to open and close types of the cat. And also in the second picture, as you see, there is an antenna which enables us to communicate with the research center in order to send our information. Let me talk about some design specifications. First of all, our design is environmental friendly. It uses both solar and wind energy to produce electricity, and also this design uses the wastewater in order to give less damage to the environment. Also, our design is smart. The solar panels and the roof are convertible, and there's a first aid kit which you can access easily. Also, there are some sport facilities and common fields that you can say that our design is socially equipped. And the last part is consist of the research facilities. We have, as Enes shown before, we have experimental setup, the workstation to analyze and report of the results. Now, let me talk about the energy analysis of the project. As you see, we have solar panels and wind turbine. These are our calculations. There is a rough calculation for solar panels and the wind turbine. These are the average values, but in total, we have about 20 kilowatts of electricity that's produced cleanly from the environment, and it's enough to just for all the purposes of this truck. And my friend Enes is gonna continue with the instrumentation part.
Now these are the instruments and experimental setups we have in our facility. There's a auger to dig up the soil. There's a soil compaction tester, which is a penetrometer in other words. There's a pH sensor, there's activity sensor, there's EC sensors, there's a moisture sensor. Actually, the most of the sensors are packed into one device. There's soil temperature sensor and soil sample containers. There's also a weight scale, which is a load cell actually with works with electricity. Now these are all soil type sensors, and in the next slide we have weather type instruments. We also want to look at the humidity of the air and temperature of the air. The pressure, we can look at the GPS or GNSS data to determine our position. There is anemometer to see the wind speed. There's a pyranometer and a windsock to see the wind's direction, actually. And this is all for our presentation. Thank you for listening to us. If there's any question you have, we can answer them.
All right, now if any of the jury has any questions, you can unmute and ask. Then our jury is going to give points to you, and in the end, we are going to review that.
Okay, I have a question. Can I go ahead and ask? Or
Yes, of course.
Sure.
Okay, thank you very much, guys. It was very nice, and I really like your presentation. I have a quick question. You are putting all these expensive experimental stuff such as solar panels and wind turbine. Did you have any cost analysis? How much this thing is going to cost?
Actually, we haven't done the cost analysis part since the requirements of the project does not require any cost analysis. But actually we haven't done it.
Okay, thank you.
I also have a question to you. Thanks for your great effort. I really like the project. However, I couldn't see the wind turbine in the drawings. Can you show it, or?
The thing is, the wind turbine is we couldn't model wind turbine accurately in the, in the project time. So it's not in here. But we think about the, cylindrical wind turbines. These are very new, not like fan type, cylindrical, and it takes less space. So we think like this. We are storing the wind turbine, and when we get to the place, we take them out and place them in a windy place, actually.
Okay, I understand. Thank you.
I have a question as well. Thank you for the presentation. Maybe I missed that, but how do you move your car? And where is the motor? Have you thought about location of the motor, and what kind of motor is that? If it's electrical one, is solar power enough to move it? Thanks.
We have hub motors in the front wheels, in front wheel assembly, and we stack the batteries on at the bottom of the car, inside the chassis actually. According to our calculations, it's enough to move the car in a given range if we can get enough sunshine and wind speed. We can produce enough energy to move our car. Yeah.
Okay, so your design is really depending on the amount of the sun power in the end.
Yes, that's the reason is that we are not able to reach any, how can I say, charge station or something like that. So that we should produce our energy from the natural sources.
Okay, thank you.
Yeah, from my side, a little question that I understood from your presentation, which is very good also, that you are using the natural sources for the moving the vehicle. But what I understand from this picture is the solar panels is a little bit higher than the vehicle and the right side and the left side. Is there any solution about when the vehicle is on the move, how you can use these solar panels because it's a little bit right on the side is bigger?
Yes. Actually, the thing is, we did not reach the height limit, and the solar panels actually moves on top of each other with the rails. There's a three-story solar panel, and when we stop, we open them up with rails. The solar panels are not exactly in the same height, so they get on top of each other.
So you mean that the solar panels rotationally can move? This is the meaning of your explanation?
You are muted, Enes.
Not rotationally, but actually linearly. They come on top of each other.
Okay.
Okay. Also, I have some questions. Thank you very much for the presentation, first of all. That was a good effort, honestly. But guys, as far as I saw, you have focused on the duties on daily and monthly, but I couldn't see any details about the human being needs. You know, this is a 1 year long period duty. So, first of all, these scientists should have to believe it. And also you have tasks for some issues as well. Like, for example, your solutions should be friendly to the environment. And for example, how they will fit and what will they do with the garbages, for example?
Actually, I can answer this question.
Please.
That's why I choose 65 to 1 meter and 50 centimeter kitchen. Actually, it's a little bit big kitchen, and under kitchen we have a fridge, and we can put the some food in it. And also we choose a little bit large bed. Actually, it's like one single person bed. It's not actually small, so we can use the social areas in the middle of our car. And also we have my friend Akın said that social facilities, sports activities. We have yoga mats. We have yoga mats in our car, and also kettlebell like this. They can also do some exercise on our car. We think also their social life actually. And also at the top of the bed, we have baggage so they can use their own thing to use. Yes.
And the packages are planned to be resolvable. All the packages, not plastic or some other material that we cannot dispose to nature. And the food storage mostly consists of dry nutrition that are used in space missions, so that we can stack more food, more nutrition, and we can feed the scientists well throughout the process, throughout the project.
Okay, and what about the clean water to drink or to have shower? And how will you make it continuously free to have it? Did you think any details about this?
Yeah, there must be a water convection part. Unless you may want to mention that.
We have actually we thought about rainwater collecting. The thing is, the rainwater is not reliable in the end, since we don't know if it will rain or not, and the rainwater might not be very reliable actually, and the thing is, we should have a water source. We have a large storage room, but in the end, the storage is not gonna last 1 year, of course. So we think that the car or the people will need to get outside help.
Okay.
To refill their water storage.
Okay, thank you. And also just a quick question about your solar energy calculation. Can you go back to that slide, please? Okay. This average sun value comes from where?
Actually, the project in the project requirements, there is not a specific area for the solar radiation amount average of it. So in total, there's a NASA document, but it's not provided in here. States that about this amount of solar irradiation can be obtained from the sun per an average of per year, actually.
Okay. Okay, thank you very much, guys.
I want to add that there's a water purification system at top of the driver's cabinet. There's a place, if I can show us the 3D picture of the car. Yeah, there's a place that you can see on top of the driver's cabinet. The space is enough to integrate a water purification system that works with electricity and some filters and something else, so that we can use our used water again and again. At the end, we may need another water source. But I'm not sure if the nature can help us in this topic.
Thank you.
All right, if we don't have any other questions, we want to thank the team Nachkriegskinder. And now we can move on to the next team. Once again, thank you for your presentations and see you at the official closing part.
Thank you.
See you. Thank you.
Thank you very much.
The next team is the team Easy Team. Are you here?
Yes,
Easy
we're here.
Team.
Yes.
All right. So who is going to share the screen? So
I will do the sharing.
all right. I made you the co-host. Now we can share our screen. Good. We have at max 10 minutes for your presentations, then 10 minutes for the question part. So at 6, it will be better that we finish the team. And good luck.
Can you see the presentation now?
Yes, we can.
Okay, then I am starting. Hello, everyone. I am Furkan from Electrical and Electronics Engineering Department. I am a third-year student. Here with my friends Nehir and Aybars, they are from Mechanical Engineering. And now I'm going to present you our solution to the problem, to the research dwelling unit task that EBEC topic team gave us. So here we first tried to state the problem, divide the problem to 5 different parts that what scientists needs to do on the field, and we take this problem into hand in 5 different parts. They are accommodation, storage, power, transportation, and scientific tools they need. For the accommodation part, covers the needs of the people, their humane needs of the scientists, like living and resting, their personal hygiene and exercise. Storage, that name implies all the storage stuff like food, water, or the samples that should be taken to research base, or the batteries is also a storage unit because it takes a significant amount of volume and mass in the car. Then we go to the power part, which is the energy that provided to car for all the work that should be done, both transportation and living and scientific works. We decided to use solar panels and batteries for the power needs of the car or of the vehicle, and a small basic power calculation is also integrated when we come to the power section of the presentation. After that, we got the transportation part, which enables the vehicle to move around the field. We have motors. We decided to use tracks for off-road driving, which we think it would make off-road driving easier with tracks. We got a foldable solar panel. When we move, we can fold the solar panels and have a better moving. Then we got the stake brakes, and the name doesn't actually explain what it is, and when we come to that, I will explain it. For the scientific tools, actually, we did not invest too much on this part. Like, since we are not weather engineers, we cannot know the specific needs they need. But what they need is get soil samples from the ground and take weather measurements. And we built the necessary infrastructure for this, but not get into too much detail how they will do their work. We left that part to the scientists. So I am moving on to the general drawing of the vehicle. So basically, I want to just talk about some of the parts. In the back of the car, if you can't see my mouse, can you confirm? Do you can see it?
Yes, we can see it.
Yes.
Oh, okay. In this part, we have the main living and resting room in the back of the car, back of the vehicle. They do actually all the work in here. They live in here. They keep their meetings in here, and we have a convertible type of room here. On the front, we have the control panel of the car, and you can see the locomotion tracks in here. And we have cameras and air conditioners. Basically, I will go back to this figure when their parts are come. So I am just moving on right now. The first part of the project I want to talk is accommodation, how the residents will continue their lives in the vehicle. First, I've talked about living and resting area. In the vehicle research dwelling unit, we have a limited space that is specified in the document of project. So we cannot just use this space in our will. So we wanted to have a compressed, like use the field effectively, use the area effectively. For this purpose, we designed a room that can be interchanged as a meeting room or as a resting room. The tables and chairs here can be converted to beds. Actually, they are designed in this way when the resting time comes, and we use the space effectively with this method. After that, we have a bathroom to ensure their hygiene. And we positioned this bathroom close to the water storage we have in order to have an effective water transformation between bathroom and water storage. After that, we have an exercise station where they need daily exercise. Normally, exercise is planned as outdoor exercise, but that cannot be always possible when there is a bad weather condition or the terrain does not help with running, or it can prevent the physical exercise outdoor. So when this kind of situation happens, they will do their exercise in this small exercise station, and I want to just simply show them in the figure I mentioned. Sorry about that. So this part is our exercise station. It is not very representative here, but as it's taught. And this side is the bathroom before the living area. I want to continue. We have a first aid and medicine part. The basic healthcare equipment is available in the vehicle, but the vaccines and medicine can be spoiled if put in the outer weather conditions like room temperature. So we have refrigerated cabinets to keep them cool and fresh. After this, I come to the storage part. For storage, you can see in the image, we keep all our storage under the vehicle. Like here, we have a thickness under our area, and our storage is basically here, all our storage, food, water, and batteries. Food storage will be 1 year full of food stock, and it will be taken before the going to expedition, like from the base of the research, and all the food they need will be with them as long as the research continues for 1 year. And this food cannot be fresh food. It has to be a dry or canned food, because we do not want to use energy and space for refrigerated storage, and that will consume much of our energy if we need that. So only dry and canned food will be taken together with the scientists. After that, we have water storage. Water supply problem have two kinds of solution. First one is the rainwater. Rainwater will be stored and filtered to obtain drinkable water. Since our scientists are weather scientists. They can pre-calculate how much rain will be available to them when they go to research. Obviously they won't pinpoint this much rain will drop this day, but they can have an average idea of how much rain they are going to have, and they can plan according to that. And this won't be the only water source they have. In addition to that, when there is no rain but they need water, there after our research generated built by the General Electric company, air to water is what they call it. It is a prototype right now, and picture is one of their prototypes picture. So they can interchangeably use this, and this can be taught as an analogy to electricity generation in the grid today. Like when we have renewable energy like wind and solar, but they are not reliable. They can be there sometimes, but they are not. And when this happens in today's world, we use the natural gas to compensate for this lack of energy. And these two sources we have when air to water atmospheric generator can be told as the natural gas available anytime, but not used all the time. And rainwater can be told as the renewable wind and solar. They can be, it can be available when it provides a lot of water, but when it is not, we need another source, and this is when air to water comes in. When I'm continuing to other storage types, and sample storage is another type we need. We can do some analysis on the vehicle, but we have limited space. We cannot fit all the scientific instrument onto this vehicle. So for this reason, we need to take some samples back to the research base where we have all the equipment we need. For this purpose, a dedicated sample storage area is built again under the car for soil samples and water maybe. Battery is again stored under the vehicle, but I will talk about the battery in more detail when the power part comes in.
Actually, it's your last minute.
Part.
Maybe you can hurry up a little bit.
Can you hear me now?
Yes, we can hear you now.
Okay, I'm sharing again. Sorry for the...
Did you hear me?
I won't go. Yeah, I can.
Okay, you should hurry up.
I won't go into too much detail. We have a power calculation with 25% efficient solar panels. Current best panels are actually at 22% range, but they will increase with technology increase. And with this, we have a roof area of 15 meters squared, and we have this area by foldable panels because that much area is not available on top of the car. And when we have foldable panels, we can increase this area to 15 meter squared, and we have a 3.75 kilowatts of power regarding to this equation. And today, the best, like Tesla's best cars use 160 watt-hour per kilogram batteries, and with 600 kilogram of these batteries, we can store 96 kilowatts of energy. And when we look at the average daily power consumption of ours, we have around 29 kilowatt per hour. And since our vehicle is built with scientific instruments and a lot of work should be done, we have assumed it to be 40 kilowatts for our vehicle. With these numbers, we can power our vehicle more than 2 days with battery power, and we can charge our batteries in 2 days with when solar is available. So I come to the transportation part. We have a motors, like I do not focus too much on this because most of the time vehicle will be staying in position and doing research, and tracks are therefore to navigate easily on mountain area. Brake stakes are what you can see on a fire truck or a crane. It is fixing the car on the space, and we have claw-like types to have our vehicle level on the uneven terrain and keep it stable, like when stormy weather or something comes in. And we have the scientific tools. As I said, we did not focus too much on this. We have a soil drill that can get samples from the soil, and we have a weather measurement tool in the roof of our car together with the solar samples, solar panels. Thank you for listening. Sorry for the last part. I need to get a faster time.
All right, we exceed the time like 3 minutes, but that's okay. So if any of our jury has a question, you can just unmute and ask. We have 4 more teams, each for 20 minutes, and we need to be done by 7 past 45. So we can ask our questions accordingly. And we can see your screen now, Furkan, still.
Okay.
Oh, sorry.
All right, our jury.
Okay, I can start with the question, if it's okay. You said that you can charge the batteries in 2 days, and with these batteries, you can spend that energy in 2 days as well. But if it is, if there's sun, right? So
Yes.
do you have any backup plan for energy if there is no sun?
Actually, when doing the design, I have countered this problem, but I actually did not find any. Time was up, and I couldn't provide any solution. But the best solution would be with another fold of panels. I could not find any other solution. And actually, the 40 watts we have is not always going to be consumed 40 watts, 40 kilowatts. Sometimes we are going to use all the power, like air conditioners are on, scientific tools are on, they are all working. When this condition happens, we are going to spend 40 watts and 40 kilowatts hour, but maybe sometime in the night, we don't have the lights on, we are not doing nothing but keeping the vehicle in the living temperature. And these conditions also actually will increase the battery using time from the 2 days. 2 days is the maximum use of power.
Okay, thank you. And also another quick question. I don't remember there is a solution for the medical checkup. Do you have any details for medical checkup?
No, not for the medical checkup, but we have the first aid and the vaccination and medicine problem solved. But for the medical checkup, we did not include that, yes.
It was in the list for monthly routines, right?
I couldn't catch.
The medical checkup was on the list for monthly tasks.
Yes, it is.
Okay. Okay, thank you guys. Just a quick information. You have a soil drill equipment. That was a good idea. Congratulations for that one. And it was a good detail. If you have a drill machine, maybe you can consider the heat pump equipments for the alternative energy sources. Just for information, okay? Thank you very much for your good effort.
Before you finished your words, my friend actually forgot to say about the sports part of our project. Actually, we designed our sports facilities that is a single-wheel bicycle can produce a little bit of energy that actually power the computers or air generators inside the track. But my friend skipped this part, so I would like to remember this part.
Yes.
Good idea, thank you.
Yeah, Ayberk mentioned, but he was quite brief. Thank you very much, Furkan. It was very nicely explained. Did you ever work out on the layout, like how everything is gonna look from the bird view? Like, did you try to draw anything so that you kind of have chance to optimize how everything is gonna fit together or not? Layout meaning that did you draw any two-dimensional plan view showing how everything is gonna fit together?
Okay, design was made by actually Aybars. I think he should answer this better than me.
If I didn't understand you wrongly, you talked about case specifications for CAD design. You asked it about, right?
I am asking about the plan view of the layout.
Plan view of the layout. Actually, we did not have any special planning layout for CAD designs and project designs. We just noted our instruments and our needs at very beginning of this competition and started to drawing CAD designs because we had lost actually one team member of in our team, so we didn't have that much time actually. So that's it.
Oh, that's okay. It is part of learning anyways. Because in real life also you will lose people, so it's a good experience for you. So you should be happy about it. Okay, last question for you. Did you look into the weight of all these things? Like how heavy is your machine or your tank or whatever you want to call it?
Actually, we calculated our mass. It doesn't reach up to 6 tons that is written at the project's requirements. It's nearly 5.5 tons, but we unfortunately forgot to add these calculations in
That's
our
okay.
presentation.
That's okay. It was very nice anyways. Furkan explained very nicely. Thank you very much, guys. Appreciate it.
You're welcome.
And I have one. You showed us 8 cameras around the RV. What is the exact function of them? Cameras.
Since we don't have a glass panel of the front of the car, actually we don't see our front views, and we actually don't have the chance to bring our heads into the to see the right and left views. So we actually fully inside. We are actually fully inside the car. So we might consider our all rocks and interruptions in our environment. So 8 cameras can showing us our information with this panel we draw here accordingly. So those are the needs for the cameras.
I also have a question. I guess I'm the last one. Guys, I wonder how the communication will be proceeded. I mean, you haven't provided any details for internet, electricity, etc.
We actually talked about our solar for electricity. Our battery actually will distribute the power inside the car, not for only for the wheels. We planned for it actually. For internet, we actually had a sensors and the Wi-Fi or any communication box to the back of the or front of the, I don't remember it very well. It's a small.
This one, yeah.
Yeah, this console actually measures and sends the data from the computer or from the environment efficiently. We actually designed for it. If Furkan may forgot to mention it, we are sorry for that.
Okay, no problem. But I have a last feedback for you. This is a project for field research. I mean, for at least I was expecting to see at least some details about soil sampling, for example, or field research equipments. It's just a feedback for you, but thanks for your great effort.
You're welcome.
All right, I think we have no more questions. We want to thank EZE team again for their presentation and see you on the official closing. Now for the team design category, we have 4 teams left and nearly 20 minutes for each team, and we'll be done by 7:30 hopefully. Now the next team is, the name is Yatırım Tavsiyesi Değildir. Are they here?
Yes, we are.
All right. So who wants to share the screen?
I will share the screen and my friend will make the presentation.
All right, I'm making a co-host right now. You have 10 minutes for your presentation, so please hurry up on that. If you exceed the time, there can be a deduction. So your time starts now.
So you can see my screen, right?
Yeah, of course.
And you can hear me, right?
Yes.
All right. So hello, everyone. I'm Güneş, and we're gonna present our DUI design. And all right, so let's get with it. So our design purpose here, of course, is the most important part of our project. Actually, is to provide an accommodation on a rough environment that is on a mountainous top, actually, and provide us with the ability to conduct experiments that may, that may very well be sophisticated or just simple experiments. We want to combine these two purposes and present them in a feasible solution to you. All right. So, can you go to the next slide? Right. So, of course, our design considerations will generally be concerned with these 3 issues, which are daily requirements, monthly requirements, and system-based requirements. And of course, these requirements are integral in our analysis and design, actually. And of course, if we solve them correctly, we can, at least for a preliminary efforts, we can create something, I guess, that is acceptable. All right. So of course, let's start with daily requirements. Well, as mentioned in the PDF document, well, their daily requirements are, of course, will be carried on every day, so they need to be realized with some, certainties. So of course, our first and most important topic maybe is solid sample collection, and we're gonna do these with external drills and dippers mounted on the side of the RDU. And by external drills and dippers, I mean a smaller version of those drills and dippers mounted on excavators. You can think of it like that. They will be robot arms, and they will have 6 degrees of rotationality, and accordingly, they will be numerically controlled from computers. And this will allow us a great deal of flexibility in conducting our experiments. And maybe, if you want to drill some hard rock, we can just utilize our vehicle and do it accordingly. This will greatly simplify our efforts. And of course, that's fun. So the other is examination and analysis of samples. So of course, we collect our samples, then we need to examine and analyze these samples. So how are we going to do that? There are 3 types of samples that we mainly collect. These are inorganic materials, organic materials, and water. So generally, inorganic materials can be analyzed in 3 different ways, which can all be done actually. And we actually, as we don't know the specific needs of this vehicle and these scientists, we proposed all of them in unison, and they are flow injection analysis, segment flow analysis, and near-infrared scanning. They can be utilized according to the needs of the scientists. For organic materials, we have a light microscope on board, which will be presented on the table in the next slides, actually. And for water, we have soil moisture sensors. Right. So of course, now that we collected our samples, analyzed them, we need to report them, and the reportings. And of course, we need to report them to 100 kilometers away. That's a long distance. Therefore, we want strong radio transmitters that can provide us with the ample signals. And of course, our another daily requirement is observing air temperature and humidity. We do these with different kinds of sensors and different kinds of devices. The simple ones include thermometers, barometers, and anemometers, or altimeters, of course, if you want them. And these are all our daily requirements. So let's consider our monthly requirements. Right. Now monthly requirements. These are more general, and of course will be conducted less regularly. So first of all, we need to observe the seasonal intensity and habitat change. And of course, these actually very well go in unison with the daily requirements. Most of them are we need to observe seasonal change observe habitat change, soil analysis. These are all, of course, can be done daily as well. So I won't mention them in a second time. But the important thing here is that we need to also conduct some time analysis and process analysis. And of course, these can only be done once we obtain a sufficient amount of information. We also have our vaccinations, which will be provided in dedicated compartments for vaccinations, and these vaccinations will be stored in refrigerant systems. And of course, we also have our vehicle maintenance, which will be done with general purpose tools such as sockets, sets, wrenches, and screwdrivers, which will also be provided in the dedicated compartments. That's it. And of course, now the most important part is system requirements. Well, of course, we need to figure them on a preliminary basis to actually realize the feasibility of our system. So let's first begin with the thermal requirements. This is actually most important because we can be in a harsh environment. There can be winter, or it may be very, very hot. It may be very, very cold. We need to stand these harsh environmental atmospheric changes. It will be on the next slide, thermal requirements. Right, so of course we devise embedded immersion heaters to overcome these. These will be present in the sides and the front and rear of our vehicle, which will be embedded actually in the in the steel parts of the vehicle. And of course, we will present sufficient thermal insulation, like 2 or 3 centimeters of sufficient thermal insulation, which will mainly be done with aerogels or such foamy materials. Okay, that's it. And then we have mechanical requirements. We'll propose actually 2 to 3 centimeters of exterior structure of titanium alloy steel. We chose titanium because it's lightweight and it's quite strong. It will minimize torque and minimize thrust, whilst providing us with sufficient strength. Okay, then of course we have acoustic requirements. Acoustics actually is quite important because our engine will be running, it will be producing lots of noises, and it can get too much frustrating. So we devised some foamy structure around our engine to minimize this. Then of course we have our engine requirements. In the next slide. Oh, I'm sorry. We have our hardware requirements, which will be actually where we will conduct our analysis. We will provide some desktops with analytical and numerical applications and antennas that can transmit these analysis as reports to the centers. And of course, then we have engine requirements. Like I said, we need sufficient torque and thrust supply, and we definitely need some sort of a renewable energy approach. Therefore, we think hybrid energy consumption is the best option here. We actually talk about nuclear energy and just fossil fuel or other such applications, but they wouldn't be much feasible as fossil fuels are generally non-environmental friendly, and nuclear energy requires a great deal of cost, a great deal of money, and it requires a great deal of space. Also, is only electrical approaches wouldn't work in our opinion, because electrical approaches generally consider the system as it just couldn't provide the sufficient power required for the system. So we devised a hybrid energy consumption system. That's for engines. Then of course we have our tire requirements. So our tires will be generally on rough roads, and therefore we propose off-road tires, which have high-grade suspensions with vibrational control, which will be numerically integrated into our system. Then, of course, other than that, we have hydraulic and rail system requirements. Of course, our digger and drills, excavator digger and drills will function hydraulically, and our system, the top of the car, the top of the vehicle can be opened through a convertible design, which will be actuated with rail systems. Then, of course, we have human needs such as hygiene needs that will be conducted with wet pipes, towels, toothbrushes, nutritional needs, physical exercise needs, and such. Of course, physical exercises will generally be done on anywhere actually we want, because we want our sciences to be on a flexible environment. That then we don't want them to be stressed. We want them to just do what they want, and if they want to exercise a bit, they can just exercise. And the same goes for sleep. They can just pull their bed sheets from a place and sleep on there. And that is it for our human needs. Then, of course, we have our energy productions. We actually calculated this according to some sample analysis we saw on the internet. And accordingly, we found that wind turbines and solar turbines produce this much of energy, and they can be used in our calculations and in our efforts. That's energy production. And we did our breadth calculations. We can refer to them later on, but I got so little time, so I'm going to pass them. Our breadth calculations are here, and our power consumptions are here. And now I'm passing it to Çınar to present.
Yeah, now I will talk about the inner design. We have lots of storage and lots of tables so that people can work and study the samples they have taken. We have bunk beds which will be opened and serve as sleeping quarters. This is the back image. It's also like that. This is the right place. We have the door and the workbench, which are with storages and the seats. This is from the top. We have tables to work for eating, storage, and bunk beds to sleeping. And this is the outer design. These panels on the left will open up and convert to the stationary mode when necessary and to produce the electricity and stuff. And these are the communication arrays and weather station, which will help transmit the sample data to the base. And we wanted to make it as agile as possible, so we added a six-wheel design, and we thought that tables are the most important thing to analyze data and to work with that. So thank you for listening to us.
All right, thank you for your presentation. Now, if any of the jury members have any question, we can go to there.
Yes, I can start. Okay.
Okay.
Thank you for the holistic presentation. You touched everything on the project, but you talked about a lot, but we couldn't see them in your inner design picture. Maybe how about exercise area or medical unit area? Where do you think they would go in the inner design, or do you think they would be outdoor?
Well,
have you thought about those?
Yeah, as it is shown that exercise in fresh air is the most healthy. So we thought people would exercise in the outside. But if it needs be and there's a blizzard or storm outside, this area between the bunk beds is quite large and people can like have push-ups and pull-ups in there. Also for the medical checkup area, that can also be used. So it is a quite versatile area which has storage containers nearby, and it can be used for many, many purposes. I mean, all the system is actually quite flexible with the design.
Okay, I can ask one question. Guys, first of all, I need to say that you have checked all the points. Congratulations, actually. That was a good idea to cover all the requirements and step by step. But when I see your presentation, I just feel that the study was like just a brainstorm. You know, you have discussed on the requirements, you have discussed on the tasks, and you thought about some solutions. Yes, that's good. But, you know, the study, for this study, the first part is thinking and discussing about the details. But the second part should be making it real or visible. But in your presentation, honestly, I couldn't see these details. For example, you have talked about lots of devices, but we don't know now how you will implement all of these to the vehicle. You know, saying a solar panel is okay. Saying drilling machine is okay. Saying all of these stuffs will be there and the ways will be like this. Okay, that's okay. But the issue is you need to spend some time on to make it visible, you know. So that was the weak point, honestly. And it makes to give you points on this study. This is missing, you know, it was time consuming, or you just focus on this and you believe that explaining them in words would be enough. vision on the presentation, or did you think, yes, that was the weak point on presentation?
Actually, I agree. It was a big point in our presentation, and we actually devised these in our heads, the points that you just mentioned, but we couldn't just put them on our slides and just had enough time to, articulate our thoughts in that. But we, just pointed out everything in words, and as you said, our sketches, our design sketches were, that weren't that inclusive. So yeah, that's a big point in our slides, and I totally agree actually.
Okay, just a quick feedback. Without designing them, just finding some pictures from internet for all of these devices and put them as a JPEG parts on your layout, maybe that would be better. Okay, for the next studies, just take it as feedback. Okay, thank you very much.
Okay. Thank you.
I didn't hear about your departments. Which departments are you from, guys?
Yeah, we didn't have time to mention that, but we are 3 people from the mechanical engineering and 1 friend is from electrical engineering.
Excellent. I agree with my other friend from the jury. Your presentation was very true, and Güneş explained very nicely. I think nobody else could explain all these things in a short period of time. My comment is the same way the other jury said. It will be nice, actually. I really enjoy your hand drafting. Actually, you could maybe have this as a template and draw some of the details by hand without spending too much time. That could add so much more value, I think. Even though, obviously, this is, except your tires, everything else is hand drawn. So it will be nice to see some more details by hand. At least we could visualize what you're talking about for next case, for the next competition. But you talked about everything. You try to, touch upon every single thing. But again, I always have a question with using turbines and the panels, etc. Because usually my experience is they add up to too much cost, and we as an engineer we should always optimize things. So therefore, I always when I see a wind turbine on a device, a machine like this, I question myself. But that's okay. It was a student competition, so you try to reach pretty much everything. Thank you very much. It was nice.
Thank you too for the feedback. And
lastly, I have a question. Have you checked the possibility of transporting your soil samples to the center? I mean, it from the layout, it seems very small, and I couldn't see the dimensions of the storage area. Plus, transporting your soil samples will require some additional features such as temperature control, humidity control, or vibration control. Have you prepared any features about this?
Actually, while drawing these, we drove them through NX, and it was all measured. So we thought the bottom part as extra storage, and all these parts are also storage, and we thought that in them there can be temperature control and refrigerator systems and humidity, so the things required for correct sample transportation. But unfortunately we didn't have enough time to specify every single item and device we needed for that.
Okay, thanks.
So from my side, the comments is the same with the other juries. So when I start to saw this sketch drawing at the beginning of this presentation, my expectation was to see lots of applied design and understand better from using the visualization. As they said, there's lots of brainstorming in that side and appreciated, but seeing it in the visual side, maybe next time will be much more efficient for all of us. Thank you.
Thank you.
All right, if you don't have any questions, we thank the team Yatırım Tavsiyesi Değildir for their presentations. And we will see you on the official launch for the results. And now, the next team is Team Zena. Are you here?
Yes, we are here.
Yeah,
All
we're
right,
here.
hello. So who is going to share the screen?
I'm going to share Nisa.
All right, I'm making it closed. Okay, you have 10 minutes to do your presentation and 5 to 10 minutes for the questions. When you are ready, I'm going to start the timer.
Okay, I'm gonna share now.
Okay.
Hello, we are Team Zena. We participated in as a 3 mechanical engineers and 1 industrial designer. In order to work easily in line with the brief you have given, we opened a mirror board for ourselves and what we
I think we have lost your voice. Or is it just me?
No, we lost.
Yeah, okay. All right, I stopped the timer.
Can you hear me now?
Yes.
Okay. Hello, we are Team Zena. We participated in as 3 mechanical engineers and 1 industrial designer. In order to work easily, can you skip another slide? Okay. In line with your brief, we opened the mirror board for ourselves, and what we wrote on the light yellow post-its were your demands, and the dark ones are possible solutions we find, and we set the blues as the rules we must follow. We have created a plan in line with these, and now the Ezgi will explain to you.
Voice is down again, I guess, or I am the only one who cannot hear.
No, I think it's gone again. Is it? Can anyone of you hear me? Team Zena?
Geliyor mu sesin?
Aha. Şimdi geliyor.
We planned the interior design. We thought it would be better to have foldable walls because we wanted to expand the space. As you can see, we put the beds and drawers in these extra areas. The extra space between is for the daily physical exercises. In the middle, we have the kitchen area and the kitchen closets, which has food and drinks. Also, there's a portable table for eating. For personal hygiene, we have a bathroom here. For the lab area, we have a circular table because we wanted to make the movement easier. Also, the area of usage was more efficient this way. Also, there's another circular table here for the preparation of the samples that are collected manually. Finally, we have a chair in the lab to use for medical checkups, vaccinations, blood tests, etc. So this was our plan. Now Ahmet will talk about the CAD model.
Okay, can you hear me?
Yes, we can.
Okay, hello everyone. I am Ahmet Yavuz, and today I want to talk about the CAD model briefly. First of all, I want to start with the energy issues for the caravan. And so you can see at the top, there's a solar panel, but we don't consider the calculations for the solar panel because we know that lots of practical examples in the world that lots of caravanners use the solar panels for the energy issues. So we don't use our time to calculate for the energy needed and energy comes from solar panel. And in the left-hand side of the solar panel, we have the rain collector. We know rain is the not very susceptible source for the water, but we put anyway because weather can be changed and it can be rain. So we want to collect them. And after the rain collector, we have filter system for the water storage, and the water stored in the bottom side of the caravan because we don't want we want to decrease the problematic with the vibration and some other load issues when the caravan moving. And also for the water system, we have extra pump for the we can, for example, if we have found some water channels or the lakes, we can pump it to our system with filtration, of course, and we can use them. And the right-hand side of the solar panel, we can see the some Wi-Fi antenna. And what I mean with Wi-Fi is actually Wi-Fi, because it's conducted by some researchers conducted by the IEEE show us that the Wi-Fi is new technology which is 1802.22 Wi-Fi system that can be have range up to 100 kilometers. So we can directly communicate with the research center with help of the 802.22 Wi-Fi system. For instance, if any medical emergency condition, we can directly connect with the research center and we can call some doctors or we can call some rescue team to our caravan. And I want to talk about briefly with the motor engine system. We use hybrid system because solar panel it won't be enough for the totally work engine, and we use a hybrid system for them. We can move the next slide. And you can see the interior parts of our design, and it's all for me now, and we will continue with the Nisa Tufan.
All right. Here we can see the suspension system in order to fold the walls back and forth when it's sleeping time or exercise time. As I said, we implemented hydraulic systems for this purpose. We can see more details in here about the foldable wall system. We used transparent sheets to enclose the area to protect it from the outside sources. Here we see, here we see the bed sleeping area. It is two of them actually. It is left side and one right side. Also, we have a drawer in between these two, and we saw from the plan that in the area between the two beds, we have yoga mats in order to have daily exercises. Actually, we thought of buying some exercise instruments instead of yoga, but we considered that it will be too costly and too heavy for the vehicle. And that's all for this. And our researchers can have a nice view while doing their yoga daily exercises because of the transparent sheets. Also, we have a ceiling mounted sledge system for sky observations. Actually, I want to come back to this slide. At the top, we can see a circle shape. It is designed for observation of the sky in order to gather data for the weather conditions, actually. And it works like this. You pull down the circular shape and slide it throughout the rail system. and observe the sky, whatever you do for your research purposes, and then you slide it back and it snaps into its place automatically. Actually, it's all for our presentation. We will be happy to answer your questions now.
All right, thank you for your questions, Team Zana. And now, if our jury has any question, they can just ask away.
I can start maybe. Congratulations, first of all. Thank you for your presentation. Guys, I need to say that having an industrial designer in the team was a good idea, but it makes that we can, we may want to see some more details about drawings, you know. First of all, you have checked lots of things on your daily and monthly tasks. That's okay, but visuals are a little bit weak to explain all of them. For example, do you have anything to get samples from Earth? Or what about the details of foods for 1 year? Do you have anything to show us or explain?
Actually, we plan to have a vertical farm in our compartment, but we couldn't facilitate in the sketches or the CAD. But we thought about it. We thought that we can produce our food to be more sustainable for the future. Also, the other question was
getting samples from Earth.
Okay, we planned getting samples, doing manually, and returning the samples back manually, and then processing them in the lab. We have a nice area for processing and storing them. Also, we thought that all the technological instruments to analyze them will be in the lab.
Okay, you don't have any detailed lab design visions, right?
No, we didn't have time for that actually.
Okay, last question. You mentioned that you didn't calculate the solar panel energy things, you know, but I didn't see any alternative source for the energy. If you lost the sun, what will you do?
Actually, I think because of the loss of carabiners travels around just using the sound for the energy purposes, I think that will be enough for the usage. But I think since we have the hybrid motor and we have the fuel for the using the motor, in emergency situations we can use the motor to some electricity issues to power our systems for the emergency situations when there's no sun, loss of days. I mean.
Okay, thank you.
I can ask one. If I'm not mistaken, you didn't say anything about sending the soil samples to the center. And again, can you repeat, how do you communicate with the center? Did you say Wi-Fi?
I said Wi-Fi is like V-FAR. It's the new system for the Wi-Fi communication. We've done the research part a little bit for that because we want the suitable connection with the research center. And we found that there's a technology of, by IEEE that we can range the Wi-Fi with 100 kilometers away from the research center. So we can directly send our reports and results to the research center, or we can communicate with them anytime we want, because it's just our and research center communication issue.
Okay, thank you.
So from my side, there is no question, but seems that the designing is very good. Thanks and I appreciate. But some missing points that I cannot imagine in my mind, that how we can use these technologies in our vehicle, or how we can communicate with the rail center, as some question marks in my mind. So thanks and I appreciate. Thank you very much.
All right. If we don't have further questions.
I have a question.
Okay.
My question is about the, as we can see here, the concept design, the foldable shape. I mean, it is a brilliant idea in my opinion, but I want to consider the serviceability issues about the foldable design. I mean, it's great, but will it be comfortable to sleep on a bed in the foldable part, or when the vehicle is being transported, the beds can the wall hold the beds in position in vertical form? Have you considered these engineering issues in your design?
And actually, we don't consider the people sleeping while the caravan moving, because we thought that they travel and they stay lots of time for the researching things, because when the part of the detached they can use for that, but not sleeping while transportation. And I think the question about the beds while beds issue, engineering issues about the traveling, but we don't calculate about the load part of the, because we don't have such time to calculate. But I think there is we can see like lots of example of the foldable beds in the transportation systems, and then we thought that we can use here too, also too.
Okay, thanks.
All right, I think we don't have any other questions. So thank you, Team Zena, for your presentation. Now we can move on to our next team. See you on the option closing, and before that, in the company presentation at 7:45. Thank you again, once again. So our next team is the Spot team. Are you here?
Yes, we're here.
Yeah. All right. Who's going to share the screen?
I'm going to share mine.
All right. I'm making you a co-host. I think now you can share the screen.
Let me check.
Once again, I want to remind you that you have 10 minutes for your presentation. Please try to not exceed that. And then it will be followed by a question part that will take 5 to 10 minutes. You can start when you want.
Okay, can you hear my voice?
Yes.
Okay, thank you. Hello, everyone. Good afternoon. I'm Melis Orhun, and we're going to explain our researcher dwelling unit design for you today. Our team is called Spot Team, and our team members are Emine Koyuncu, Atilla Can Aydemir, and Ali Berkay Güzel, and myself. Atilla, Berkay, and myself are from Electrical and Electronics Engineering, and Emine is from Mechanical Engineering and doing double major with Electrical and Electronics Engineering. So let's start. And the contents of our presentation are, first, we're going to talk about the RDU design, and then we're going to talk about what we did for the energy part and data analysis and equipment. And we're going to talk about the personal need, and we're going to sum up with the total mass of the vehicle. And now, first, Emine is going to explain the RDU design for you today.
Hello, everyone, again. So we actually designed a like foldable van design. So the car actually moves with this part folded on the driver's part, and when it stops, it opens like that. There are pistons, as you can see from the details. There will be pistons connected in there with revolute joints, and with a little tire. This slidable part will slide over the rails, as you can see from the section AA. When we consider the unfoldable part, next slide, please. You can see the dimensions of the unfoldable part. So our vehicle will use electric motors on both of the 4 tires, and these electric motors will be hub motors. They will be directly connected to the rim, and it will be powered by batteries. We will charge the batteries with hydrogen fuel cell. There will be hydrogen tubes connected to the back of the van, and with this hydrogen source, the fuel cell will produce energy and charge the batteries. Also, we have solar energy, and also for an emergency need, there will be a bicycle for electric bicycle for researchers to make some exercise, and there will be an energy production, a little energy production actually, but it will need the emergency help of the research team. So let me talk about the interior design of the van a little bit. Actually, there will be antennas and sensors on the upside of the driver's cabin, and when this van is expanded, there will be a space for the solar cells, and the side of the van can be used for solar cells. Solar cells will be stored in the van, and when the transportation is done, researchers will simply plug these solar cells to the plugs designed for this purpose. And actually, we designed that the kitchen part and the toilet part are at the back of the van, and they will be next to each other. There will be some storage area under the kitchen. In front of them, there will be a bicycle and a study table, and after that, there will be some experimental tables and emergency aid table again. So actually the pipes connected to the bathroom and the kitchen are expandable pipes, like straws. They will expand as the van expands, and connection never lost. And also, yeah, that's all for the mechanical design part. So we can move on next to the energy part. My friend will present it. Thank you.
Hello everyone, and I am Atilla Can Aydemir, and I will now present to you about the energy side of things. We have decided to use solar energy because we need some big amounts of energy to make this RDU sustainable. We have fridge for storage purposes of the vaccines the scientists will be doing. And after that, we will have a computer which needs to transmit some reports to the HQ. We have hair dryer, water heater, internal heating, and the 45 degrees Celsius difference is the worst case scenario. They're in a mountainous area and they will need intense heating compared to the outside. So they shall need a big amount of energy in internal heating. We will have a water distiller. We plan on having a water resource near our RDU. So we need to have a water distiller too. Next slide, please. We have 25 solar panels. They are 20% efficient, and a total of 50 meters square solar panels will produce 60 kVh per day, assuming we have 6 hours of direct sunlight per day. If you have noticed, we consume about 50 kilowatt hours per day, but we produce 60 kilowatt hours per day. We decided to produce more than 50,000 kVh because in winter months there will be less sun and we may not get 6 hours of daylight per day. Also, our scientists will exercise and 1 hour of cycling for 4 people will produce 0.4 kilowatt H per day. And next slide, please. And we will store the surplus of energy in the batteries, which is like 1 day worth of energy. And that's all for energy part. Thanks for listening to me.
I will explain data analysis now.
I'm going to be talking about the data analysis. For data analysis, we have to do soil analysis, weather analysis, and after doing that, we have to analyze and turn them into a data, and we have to send them to the HQ by our antenna. Next slide, please. For our data collection and analysis, we decided to take 3 high-performance laptops. The one laptop will be online, will be turned on 24 hours of the day. It will collect the continuous data from the weather sensors, and also it will also be communicating with the HQ. The other laptop will be used to analyze the data of the soil analysis, which I will explain. Next slide, please. For the communication, we decided to use an external satellite because it is 100 kilometers away. The HQ is 100 kilometers away. And next slide, please. I don't have time, so I have to rush this, sorry. For soil analysis, we decided to take pH, organic carbon, these, we decided to measure these quantities. And next slide, please. We decided to choose our equipment for this analysis. This is the detailed list of chemicals we need. And here you can see the main components, the main lamp components we need. The STFR meter will be doing almost all of the measurements. And we decided to collect the soil with shovel and pickaxes. And then we would use a stainless steel sieve to filter them and to only obtain the soil, not the rocks and other external particles. Next slide, please. For soil sample storage, we decided to store 2 test tubes of soil per day. At total, we decided to bring 1,000 test tube storage, and this would fit to the container. The dimensions are stated below. We decided to fit this container below the vehicle, behind the driver's cabinet, and it will be on the outside, but it will be accessed from the inside. And for the weather analysis, we decided to use these sensors. We will measure temperature, pressure, humidity, wind speed, and solar radiation. The rain gauge on the windsock would also be used, planted in the outside, and it will provide a better understanding of the weather nature of the perimeter. And this is all for the analysis part.
Okay, now, thank you. I'll talk about the personal needs of the research team there. And I'll start with the medical supplies. So first, we need to have monthly checkups. We need to check these hemoglobin, blood chemistry, blood pressure, urine analysis, electrocardiogram, and spirometer analysis. And we found that there is a portable solution to that, and there is a checkup equipment. There are various checkup equipments like these available. So we will use one of those. I will bring one of those. For medical supplies, drugs, and the vaccine, we will have first aid kits, pills for various diseases, or anti-inflammatory medicine, and we'll also have endemic vaccines, influenza and tetanus vaccines in case of emergency, or we also need them for monthly shots, and we'll store them in a fridge area as shown in the figure. So we've talked about bringing a year worth of food, but unfortunately we don't have it is too big of a mass, so we cannot carry all of it. So we'll bring 2 months of food, and then we'll grow plants with 450 to 650 nanometers of UV light. So we will have a sustainable plant growth, and we'll able to feed our research team. And about the drinking water, we cannot bring a lot of water, so we will retrieve from natural fountains, and we'll use a water distiller to make that water drinkable or usable in the experiments as well. About heating, our engineering team, our research team, and will be there for a year. So we'll need both. We'll need to heat. We'll need to make the temperature higher compared to the outer temperature. So energy left after daily use will be used to heat the vehicle, inside of the vehicle during night. So that energy will be used, and it will be decided whether to increase or decrease the heating by the research team. And about the hygiene, we'll have a compact toilet and shower area shown in the picture, and it will. We need to allocate as little space for it as possible, so that we can have beds for our research team, which are we forgot to mention. I think we were hanged from the ceiling, and we were thinking of letting them sleep in hanged beds in the vehicle. And we cannot wash their clothes. We cannot have a washing machine. It takes too much energy, so they'll hand wash their clothes. And about the total mass, we've calculated all of the requirements, and it's about 5,950 kilograms, which is below the requirement. So that's all for our presentation, and thank you for listening, and we can answer your questions now if you have them.
Thank you for your presentation. Now we can proceed to the question and answer part.
I can start. Thank you for the presentation. I think everyone did well on the logical side of their aspects, but a humble feedback. I think your visual depiction was a little bit off. Maybe you could have supported your idea with visuality. I'd like to ask, I didn't sense the creativity. Again, logic is really good, but what do you think your creative aspects of your project? What do you bring novel?
Actually, thank you for your feedback. Actually, the images were my mistakes. I couldn't prepare an interior plan, and I think yeah, we actually did some cheating on the design part. We used our logic to find the best solutions, and we didn't want to take some risks. Actually, we just tried to serve a plan that can work on these conditions.
And can I add something as well? We decided to grow a sustainable food source by UV lights and plants so that our weight requirement is not exceeded. And I think this was one of our creative parts. Thank you for your feedback.
Okay, thanks.
Okay, maybe I can ask a question. You showed that your vehicle is expandable, right?
Yeah.
So what will happen when it becomes the smaller? What about the inside equipments? You know, it's expanded.
Actually,
you have settled out everything, but
yeah.
when you make that smaller, what will the inner equipments?
About it, actually, the expandable part is like slides over the other part. So the first part stays same. The second part slides over it. There's a base under the first part space, and they are completely separate. So when you slide it over, and the equipment stays in the first side, and if you let's say connect like bathrooms or toilets at the back side of the van, the pipes, like I said, will be expandable. So when it expands, the pipes will expand too, and there will be no disconnection, I think.
Okay, for the mechanism side, that's okay. Good idea. But what about the equipments? You know, the volume will be smaller. So when you expand the vehicle, that you will settle up lots of things to use that idea. But what you do when it is just
actually I thought that we can use high tables, high length tables, so that we can just take other parts, other equipments under them. We can store it under them. So we can store the parts under these tables. And actually, we don't have beds. Yeah, the casual beds. We have entangled beds over under the ceiling, so it's easy to store them too. So actually, we have a volume advantage over these beds. So I think this storage wouldn't be a problem.
Okay, idea is good. The reason why I asked the question, now maybe you can see that as well. If you would add some visions about inner side of the vehicle to the presentation, the question will not be there now, you know, and also you will see your weak points.
Yes.
And you got the idea. It is not hard, you know. You just solve the problem in a few seconds, and you are just explaining that. Okay, this is in mind. Just put it to your presentation and get the point. Okay, that was the reason why I asked that. Actually, I was just expecting to find your answer directly. You know. Okay, thank you, guys.
Thank you. I agree with you. I see this one. Thank you.
Okay, thank you very much.
Oh, maybe I can add some points that the expandable vehicle is, I think, very good idea. It can be applicable or not, it doesn't matter today, I think. And the vertical forming is another trend on the world, that everybody tried to change their forming side in a vertical way by using the light sources, like UV sources or other ones. So this ideas is okay, but as the other my friend comments, the visualization is a little bit let's say, the 3 point. The first visual at the outdoor of the vehicle is very good because it's scalable. And some numbers on it and there's some calculations on it. It seems very good. The expectation, I think, from my side can be the indoor part of this vehicle can be much more signature in our minds, let's say. Thank you very much for your effort. I like it very much. Thank you.
Thank you for your feedback.
I have a quick question. Did you get any help from the civil engineers in the soil testing part? It was, very nice to present it. You did it by yourself?
I searched YouTube for portable soil testing labs, and I actually found a system which tested all these things. And I pulled all the chemicals from that video because I wanted it to be detailed because it was one of our main tasks, and I didn't want to spare any details. I didn't have time to talk over them, but yeah, they were all there.
Thank you. I appreciate it.
All right. If we don't have further questions. Okay. Thank you, Spot team, for your presentations and your answers. See you at the company presentation at 7:45 and then in the official closing. Now we have our last team to present in team design category. Fantastic Four. Are you guys here to present?
Yes, we are here.
All right. Who's going to share the screen?
I'm going to share the screen.
All right. I made you co-host. You can start when you want. Remember that you have 10 minutes to present and then 10 minutes to answer the questions.
Okay.
All right, start when you're ready.
Before I start, am I audible to everyone loud and clear?
Yes, I think so.
Okay. Good evening, dear jury and my dear friends. My name is Shahab and I'm from Metu Department of Civil Engineering. And today I'm here participating with 3 of my other friends, and our team is Fantastic Four. We are the Fantastic Four. So let's start. We were given a problem where 4 scientists were supposed to stay in a car, in a vehicle actually, for 1 year and conduct their research. And we were supposed to design a sustainable solution for that. So we came up with something, and today I'm going to present it in front of you here. So let's start. First of all, we begin with the content. Our presentation consists of structure and design, technical features, workspace, the energy source we used, the amenities and utilities that are provided inside, and then we come to the exterior design. We have used, employing the AutoCAD, we have designed this vehicle. Here, as you can see, it has solar panels on the sides and solar strips on the body, which can be used for power generation. We are using hydraulics for these solar panels on the side so that they can open when the car is stationary and they can close when needed be. Also, this is a dual purpose because they can provide as a shed to carry out other sports activities like exercises. If the researchers want to get out, they can do that under these sheds as well. Or other stuff, they can just, if they want to hang out, they can just go outside and do it. Secondly, we have the antennas for data sharing. We are using satellite communication because the center is quite far away. So that's what we decided. And this is how we're going to proceed with it. This is a frontal view of our design. These are the sides, as you can see, the solar panels and the sheds with the hydraulic pumps. And this is the antenna on top. And this is the front view, as is visible in the drawing. Next up is the tank treads and the tires we tried to use. Since our vehicle is going to be stationary most of the time, so we have decided to use tank treads because there are several reasons for this. Some of these they provide significant stability compared to the normal tires. Secondly, as our vehicle is going to be standing for a long time, so we don't really need much of movement. And as we know, that rubber is very easy to degrade. And if it stays in the same position, it's going to cause punctures and flat tires, which is a very big problem. So that's why we avoided this. Also, this provides stability, and we won't need any other hydraulic things, devices to keep the device stable. So that's what we also did for the stability of this part.
I'll take it on from here. Sharp.
Yes.
So on the previous design itself, Sharp.
Okay.
Yeah. So just below we have not the AutoCAD drawings that we made. Below the doors, we have a place that we're going to store our engine, because not only engine, actually generator, diesel powered generators. Additionally, I would like to point out that our dimensions are very accurate to the design. Up to you. Next, up to you, Sharp.
Okay, so also at the back here, as you can see here at this back part, we will have a big storage area for our soil facilities and the machines we're going to store here, the equipment for soil compaction, the sieve analysis, etc. All the stuff for that would be stored under here inside, because there's a big compartment in here. Next up.
Come on.
Okay, next is the internal design. And as we come inside, we have, first of all, the driving batteries. They would be under the front compartment, and the diesel generator backup, it would be in the same place. Then we have folding seats. These seats serve as sofas in the daytime, and they can serve as folded beds for two people. They can accommodate two people at the night. And this is in red, you can see a table. This is a folding table that can come out whenever they want to play cards or they want to have their food. It can just fold and come out. Here is our kitchen.
I would like to take it on from here, actually, Shab.
Okay.
We also have toilets. They're Japanese Tokyo-sized toilet. They are very extremely small. They do not take much space. You can fit a person into it. So the hygiene has been taken care of. We have a workspace there. You can put all your heavy machinery out there. We also have the sheds opening up. We did not show it here because we really wanted to show the dimensions. Show the list of the things we have. So we also have shed, but we did not show them here. And these are all the various facilities that we will have in this RV. Next chart, next.
This is what a finished product might look like, because I wanted to make a good illustration. So this is what something we have envisioned in our project.
And an important reason of keeping it was that there was a hollow space between the walls, and we can place water here. A lot of water will be comparted in those spaces, in those walls.
The next efficiency of this is it has a retractable roof like this, and it can go up, and there are glass windows on top. So it provides for great visibility and helps with the weather monitoring conditions. So they can easily do their calculations and their observance.
Although this is not a true illustration of our vehicle, this brings close to the glass doors that we want to depict, because we want them to be able to see the environment. Also, there's going to be a SOS button. The compartment down here, the white compartment, small, that is save our souls. If anytime things go out of your hand, you can just ring it up and the nearest help center will come save you, SOS. So that's a very important feature of anyone who's going for isolation.
Next up is the energy source, and Ahmed is going to explain the energy source.
I'm going to explain. So our vehicle is going to be powered by clean batteries, lithium-ion batteries. Tesla has proved that it's very useful. So for starters, it's 90% efficient compared to 35 or 40% efficiency of a diesel engine. It doesn't have maintenance costs because it doesn't have radiator, it doesn't have a wind blower, it doesn't have so many things just for engine. We don't have any of them. So it's far more, it's lighter, it's more, we don't have to pay anything for maintenance. So that's one thing out. Also, we'll be saving $1,000 per month just because it's on the fuel. Also, we always have a diesel generator as backup in case we don't see sun for a few months. We always have diesel and diesel backup. Diesel produces a lot of energy. Additionally, yeah, so we can use energy, there's no maintenance, and all the next chart, next. This data was taken from energy.com. So I got this data, and if we use our solar panels properly, and if the efficiency is up to our mark, we can have actually a surplus of 179 kilowatts hour, and which also means that we can drive 500 kilometers each month. And even if we put in the efficiency into it, we'll still be able to drive at least 200 kilometers without doubt. Additionally, there was something I did not mention initially, was we'll also be having fridge in our system, but just below the stove. We'll be keeping samples there, we'll be keeping our vaccinations there, we'll be keeping our food edibles there if it needs. Yeah, and that's it. Next chart.
Also, I wanted to mention here that we have taken care of all the medical stuff that a person normally needs. We have the blood pressure apparatus and stuff like that to take care of the daily needs of a person. And that's how we're going to proceed. We also have oxygen masks available, because since they're going to a mountainous area, they might suffer from oxygen deficiency. Next is the amenities we have. We have a cycling treadmill. Ahmed is going to tell you more about it.
All these things will be placed below the sheds. The solar panels that will hydraulically be lifted off, we'll place these things under those sheds. We'll have a gym and we'll have a recreational center, and they'll be covered very well because of those solar panels. We'll have treadmills as well. They would be able to produce energy, but they wouldn't be a major source, so we won't consider that. Next chart. As for food, we found a very good solution that US Marines, they often eat MIs, meal ready to eat. They are very nutritious and they're very healthy. And they're very minute as well. They're very compact. So that's one more thing for it. Next chart. Oh, we can also grow plants under those sheds. All those sheds will have free air to them. So you can grow plants, or you can do all activities you want. Potatoes actually are a very good source of food starch, and they're very easy to grow. They can grow nearly everywhere. So next chart. And before we end, I wanted to talk about the weight. The weight will, of course, differ because of the equipment size, which I do not know properly. But I have estimated that the weight is going to be 4.5 ton, excluding the water that will be throughout in the walls of the RV. With that, I would like to thank everyone who's here. And any questions to raise? I would like to take them.
Hello, from my side, maybe it can be the first question. First of all, very well prepared presentation. Thank you very much. Very clearly from starting point to end point. The using the tank treats instead of the wells is a good idea for this hard conditions. So, do you consider that the tank treats can create a very huge weight on the vehicle?
Actually, no. From Abraham, that's something I figured out as well. From Abraham, that's the latest tank that US has. They have created these tires that are partially, very partially out of these polymers, from which they can go 3,000 kilometers without ever needing a bit of maintenance. They cannot puncture. Let me tell you that. You can take it anywhere. They're not going to go puncture. We're not going to lose air from the tires, and they're very easy to maintain, and they're light as well. That's the new thing about it. They're light. So we won't even need very strong batteries to push them through. Of course, we will need batteries, but not very strong ones. They are not metallic. They're polymers. And the picture was different, just so if you remember, the pictures were different. They were not metal. They are polymerish.
Yeah, thank you very much.
You're welcome. Any other questions, Trace?
I have a question. I didn't see any apparatus or any soil lab features. Could you please elaborate on that?
Actually, yes, I'm going to elaborate on that.
We'll talk about that. That's the missed part. We'll be using shell-bite tubes. Now, shell-bite tubes has a unique part about it that you don't need a very hard equipment to use them. I think if anyone from geotechnical engineering is here, he'll clarify. You can use.
I'm doing masters in geotechnical engineering.
Perfect. Use shell-bite tubes, hammer into it, and you'll get disturbed samples anyway, so it's totally fine. You can take as many samples as you want. Also, I would. This was also a point very clearly written that all the humidity and temperature, all these various measurements will be embedded into the dashboard of the car itself, so you can always see it over there. So that shouldn't be a trouble. You can maintain it by heater and AC. That's another thing. If Shahab has anything to add to it, he may.
And also, as I told, that at the rear end of the car, we have a huge compartment for storing our stuff related to the soil, the measuring instruments and everything.
Okay, guys, thank you.
You're welcome. Anyone else?
I can add something. Did you cover communication issues?
Yeah,
yes, we did actually.
Our vehicle that will be in contact with satellites 24/7, and we also have a SOS, Save Our Souls. In case someone is allergic, just call it. You'll get the help anytime.
Okay.
Any other questions that I would like to clarify?
Okay. As lastly, I can add something. Actually, all the questions which I have has been asked to you. First of all, congratulations, guys. It was a good study. You almost think about all the details and you have answers for everything. That's good. That shows that you think everything actually. The only point in your presentation is about the visuals and some pictures, you know. If you would add them as well, actually that would be a perfect study. But using AutoCAD is not suitable for a study like this. Actually, I don't have any question to ask because I believe that you have all the answers. I feel that, honestly. I would like to just say that that was a great effort. Thank you.
Thank you so much. It's really an honor to hear that from you, and it's great to hear. Thank you.
Thank you.
Any other questions?
All right. If you don't have any questions, we are done for the team design presentations.
Thank you.
Now, but yeah, no, thank you for your presentation too. Now, our juries and our topic team will agree on the decision. Our competitors, we want you here at 7:45 for the company presentation. While you are watching the presentation, our juries and us will be making the final decisions. And at 8:15 on the official closing, our presenters are going to announce the winners of today's competition, and we're going to end our competition for today. Now, for 25 minutes, you are free, and at 7:45, we are waiting you here for the company presentation in the same Zoom link. Thank you all for participating, and see you.
Have a nice day.
Right now. Yep, you too.